Who's alive? You cancel, but you cancel. Mm-hmm. Cancel? Yeah. Oh, God.
All right, night, everybody.
Good night. Night.
All right, so we're gonna try to run through a few items here quickly. Um, it's lovely if we all have the text; it's easier for us to follow. But the first item is as follows. It says, and everybody can see my screen, right?
Yes.
All right, cool. It says here, reading from the text, if 3 kilograms of flour costs $90, what is the cost of 15 kilograms of the same flour? So, the first thing we need to do is work out what is the cost for 1 kilogram of flour. So, if we have 3 kilograms that cost 90, what is the cost of 1 kilogram of flour? How would do that one?
We're going to divide the 90 by the 3.
Yes. So, if we have 90 and we divide that by 3, then it would work out to be what?
$30.
it, it would work out to be $30 for each kilogram. 3 into itself one time, 3 into 9 goes 3, 3 into 0, 0, and we have 30. All right, so now we know that we have 15. So what would we need to do to solve for x now?
So 30 multiplied by 15 kilograms.
By 15, all right, 15 kilograms. So we could say our 15 like so and multiply it by 30. 0 here as our placeholder. 3 fives would be what? 15, right? 5 and carry 1, 3 ones 3 and 1 what? 4. So our 15 kilograms should cost what? 450
$450.
$450. How can we prove that this is correct? Um, any ideas? If we're working with a ratio like this, 3 to 90 and 15 to 450, how do we know that this is correct? Any ideas?
No.
All right, well, you can look if both sides would be equal to the same thing if you reduce and see if you have the same stuff being balanced, right? So in essence then 0 cancel 0. um 3 into 9 would go 3 times, and 3 into 45 would go 15 times. So on both sides would end up with the same figures, so we know that our ratios would be balanced. All right, so whatever this figure is, it would be balanced with the other side. All right.
Yes, sir.
All right, cool. Okay, so let's move now to the next item. So next page. All right. So this one says a container holds 1 3/4 liters of water. How many containers can be filled from 59 liters of water? So how many of those containers could be filled with from the not 59, 49 liters of water rather? So setting this out, so we have one like this, and this one can hold 1 3/4. Yeah, that's what it says. Yes. And then we have a larger container that has 49 liters. How many of these little ones can we get out of this big one? So what would we need to do in that setup?
We start adding the 1 whole and 3/4 liters until you get enough to hold into the 49 liters.
Okay, that's one way of looking at it. Fine. And I guess that would work if you added it so many times. But I looked at it like this, saying that I could if this was empty, I could dip this one into this one and keep taking it out and see how many times I could take it out, right? And that would be repeated subtraction, right? Now, repeated subtraction mathematically can be, called division. So we could then say 49, and we divide that by 1 3/4. Okay. Now, to make
Yes,
this a
sir.
nice and neat fraction, then I could do like this and put the 49 over 1, right? Change my mixed number here to an improper fraction. So again, this would be 49 over 1 divided by 4 times 1 is 4. 4 and 3, the numerator would make 7
7,
over 4.
4.
Okay, but we're not done yet, because when we are working with any division problem, it's really a multiplication problem in disguise. So we're going to keep the dividend, we're going to change the sign and flip the divisor. All right, so we keep change and flip. So let's go with that now. So we're going to say, hold on, let me switch colors. We're going to say 49 over 1 multiplied now by 4 over what? 7. So now we could reduce as best as possible. We could now say, let me go back to red. We could say 7 into itself one time and 7 into 49. How many times would that go?
7.
All right, 7 7 is 49. Cool. So now, completing the simple multiplication problem, it would be numerator by numerator and denominator by denominator. So 7 fours would give us what?
7 fours. 7 fours would be 14. 7 fours are 28. 28.
Good. So it's 28 over 1. And we know that any number divided by 1 remains the same. So our answer here is 28. So basically what we're saying is that if I had 49 liters in one container, one big container, and I had another smaller container which could only hold 1 3/4 of a liter, 28 of those little ones can come out of this big one. All right. Mathematically, how could I then go and check my answer to make sure that that is correct? Any idea? If you were to multiply the fourth, not multiply, yes. If I were to reverse the operations, then I could always double check my answer. All right. So just remember that if we use one operation to go one way, to double check, we could use the operation to go the other way, and we make sure that what we have done is correct. All right. Got that?
Yes, sir.
So tell me what me do again. How me reason it out? I have one big container, and I can take this one out of it repeatedly. That's why I said repeated subtraction, and that's the same as division. So I set it out here, and we say that what? It would be 49 divided by 1 3/4. And then when we work that down, we get 28. All right. And if we wanted to check, we just reverse our operations and make sure that everything is balanced. Okay.
Yes, sir.
All right. Next one. All right. This one says if 1/5 of my money is $80, what is 50% of my money? All right. If 1/5 of my money is $80, what is 50% of my money? So again, a fractional problem. So I said that 1/5 of something, I'm going to use this now as my variable. I don't know what this is, right? So 1/5 of some money that I don't know how much it is $8. And then what is 50%? And 50% as a fraction, we know is what? 50 over what? 100. And when we work that down, we are going to get a half. That's why I have here a half and not 50%. So it would easily be read as what is half of the money. Understand where I'm going with that?
Yes, sir.
You get that? All right, cool.
Yes, sir.
So now I want to find what the whole is, right? I want to find out what the whole amount of money is, that when I took 1/5 of it would be $8. So what we could do in this case, I'm going to switch to purple. We could multiply and think of this as the left-hand side and the right-hand side. All right. So over on this side, I want to get this unknown amount of money by itself. So I can multiply 1/5 by its reciprocal, which is what? 5/1. Anything I do to the left-hand side, so if this is the left-hand side, I need to do that very same thing to the right-hand
Right
side
hand
as well.
side.
So here I go, I multiply this side by 1/5. So now I also need to multiply the right-hand side by,
Yeah.
not 1/5
Yeah.
rather, the
Five.
reciprocal, which is 5/1. I need to multiply this side by
Five
five
over
over
one.
1, make this into a nice neat fraction, and then I will reduce on this side. So changing color now, that one will cancel this one will cancel this one, leaving me with the unknown amount, or the whole, over here. And then numerator by numerator would be what? 80 by 5, which
Eighty.
gives me a total of what?
400. 400? Yes.
How
5
much?
over 4. 400. 400.
400. All right, because remember now, 5 times 0 is 0 in the ones place, and then
5
5
over
8 will
4.
give you
5,
40.
8,
So
40.
4. So this is telling me now that the money that I had to begin with, that I did not know, is actually $400, right? So if this is $400 and we find that out, then it's easy for us to answer the second part of the question that says, what is 50% of my money? So what's a half? Remember that 50% is a half, you know. So what is a
Um,
half of this?
this, 400, 200. 200.
So a half of it should be what? $200.
100.
All right, so let's go over this again and see if we have this right, right? So it
Yes,
says,
sir.
if 1/5 of my money is $80, what is
What
50%
is
of my money,
50% of it?
right? So again, we need to find the whole first, and then when we find the whole, then we find 50% of the whole. And in this case, what we had to do, we had to find the reciprocal of 1/5, which is 5/1, multiply that on the left hand side, and then when we're done with that, we'll do the same thing to the right hand side to make sure that we are being balanced. That worked out to be 400, so we know that the whole is 400. And then quite easily, 50% of that would have been 50% of that would have been $200.
$100.
All right. All right.
Yes, sir.
Hold on a second now. Okay. So we'll finish now. Here we go. Another one says, as part of a recipe, the chef mixes 12 teaspoons of flour to 8 teaspoons of sugar. What fraction of the mixture is sugar? All right, so let's try see if we get this. So we have 12 teaspoons here to 8 teaspoons here. If we were to look at this as a ratio, it would be 12. We'd add these terms and get 12 to 8. And this would make 20 as the whole. So it would mean that the, let me see which one goes first. Okay, so if this is flour, that means that this 8 is the sugar here. So it means that the sugar as a fraction would be 12 parts out of 20. No, the flour would be 12 parts out of 20. And the sugar would be 8 parts out of 20. All right. Now, if it asks us to say what part of the mixture is sugar, then we know that it's 8 parts out of 20. How else could we represent 8 parts out of 20? We can reduce this, right?
Yes, sir.
If we were supposed to reduce this, what could we reduce this to be? When we're reducing fractions, what do we need to find?
You see? Yes.
The highest common factor of 8 and 20. What's the
20.
highest common factor of 8 and 20 now?
4.
4. Okay. So 4 could go into 8 2 times, and 4 could go into 25 times. So we could say that the sugar here represents 2/5 of that particular mixture. All right. So it's just a fractional problem, and we are, looking how we can express this mixture as a fraction. All right, last one. Last one. Next page. Okay. So this one quite similar again to the setup for the first one that we had. It says here, let me read it for you. If 12 mangoes cost $360, what is the cost of 16 such mangoes? 12 mangoes, 12 mangoes cost 360.
360.
How much money are we going to pay for 16 of those same mangoes? So first thing we need to do, we need to find the cost of one such
One.
mango. So what's the what would be the cost for one such mango? So we could say what the total, is like if we, all right, if we went to the tuck shop and they said that one lays, right? No, one lays at the tuck shop is for, okay, I gave them $100 and I get 2 lays. What's the cost for one lays?
Yes, 50.
50. Okay, so it's the same concept here. So now I know what the total is, 360, and I know that I have 12, so we could divide this into it, right? And then we find out what the cost of one is. So what would the cost of one be here?
12 into
12 and 12 1 and 12 into 36 or 3 times. So 3 12 1. 3 times.
Okay, almost there.
30?
30 would be what we're looking for, because 12 into itself one time, 12 into 36 goes 3 times, and 12 into this 0, 0. So the cost of one such mango would be what? $30. Cool? So if one mango is for $30, right, then the cost of 16 of them would simply be whatever the product of 16 and 30 is. So we have 16 and we multiply that now by 30. Put our placeholder here. And then we say 6 threes would give us what?
18.
Right, 8 and carry 1. And then 3 ones 3. And 1 would give us 4. So our answer should be about $480. $480 for 16 such mangoes. Okay. Again, I think that if we go 12 to 360 and 16 to 480, if we reduce, we should be seeing something similar to this. Here we go. 12 into this will go 3 times, 12 into this 4. And can we reduce this? 4 into this would go 3 times, and 4 into this 4. You notice that we have 3 to 3 and 4 to 4. So the ratios here would be equivalent. All right. I hope that helps a little bit in terms of going through those. If you have any questions, then we can look at them tomorrow, or you can ask me to help you go through those. All right.
Yes. Yes, sir. Thanks.
All right. Take care, guys. We'll see you tomorrow.
Okay.